Hi students, this is Sivakumar. 11th Standard Mathematics, Chapter number 3, Exercise 3.3. Trigonometric functions and their properties. Trigonometric functions and their properties. So, trigonometric functions and their properties. Here, I consider x-axis and y-axis. X-axis and y-axis. I divide the circle into 4 quadrants. Each quadrant is a sector of having the central angle as 90 degrees. This is the first quadrant. Second quadrant, we have to consider in anti-clockwise direction only. Anti-clockwise means positive direction. Clockwise, that is negative direction. Remember, first quadrant, second quadrant, third quadrant, that is fourth quadrant. You know that one rotation represents 360 degrees. Full rotation, that is 360 degree. I start with the 0 degree. Here 0 degree. I am traveling in a circular path in anti-clockwise direction. That means positive direction. Okay. From here to here 90 degrees. 90 plus 90, 180 degrees. 180 plus 90, 270 degrees. 270 plus 90, this is 360 degrees. Okay. I start from here and I reach the same place. So full rotation, 360 degrees. Now I am going in clockwise direction. Start from here, that is 0 degree only. From here to here, this is minus 90 degree. Okay, so negative angle minus 90 degree. Then minus 90 that is minus 180 degrees. Minus 180 minus 90, that is equal to minus 270 degrees. Minus 270 minus 90, that is minus 360 degrees. So if you rotate in clockwise direction, you will be getting a negative angle. If you rotate in anti-clockwise direction, that's a counterclockwise direction, you will be getting a positive angle. Right? Now, here I write A. A represents all. In first quadrant, all trigonometric ratios and all positive. Sine, cos, tan, cosecant, secant, cot, everything is positive in first quadrant. Second quadrant, S refers sine. Sine and its reciprocal cosecant. You know very well the reciprocal of cosecant theta is sine theta. Reciprocal of sine theta is cosecant theta. So sine theta and cosecant theta are reciprocal of each other. Remember, here sine and cosecant only positive, others and all negative. Third quadrant, T refers tan. Tan and its reciprocal cot. Tan theta and cot theta are reciprocal of each other. So tan and cot only positive, others and all negative. I write here sine, S refers sine, all, tan, and in fourth quadrant C refers cos. Cos and its reciprocal, that is cosine. Sorry, not cosine. Even you can write cosine. Cos is the short form of cosine. Okay. Cos and its reciprocal, secant only positive, others and all negative. So A, S, T, C. For easy remembering, we can consider as all students take coffee. or all silver teacups. Just for remembering only I'm telling, right? Again I tell you, here all positive. Sine and cosecant only positive, tan and cot only positive, here cos and secant only positive. Now we can take the angle in counterclockwise direction, that is anti-clockwise direction. Here 0 degree, this portion represents 0 degree plus theta, or we can say 360 degree plus theta, 0 plus 360 in first quadrant, like that. Here 90 degree, so this portion 90 degree plus theta, 90 degree plus theta. This portion, since we have 180, here 180 plus theta. This portion 270 plus theta. Full of anti-clockwise direction. Again I tell you, first quadrant 0 plus theta, second quadrant 90 plus theta, third quadrant 180 plus theta, fourth quadrant 270 plus theta. Now we can take the angle in clockwise direction. Okay, here 360 degree, 360 degree minus theta here. Here 270, so this quadrant represents 270 degree minus theta, full of clockwise direction. Here 180, this one represents 180 degree minus theta, second quadrant. First quadrant, here we have 90, no, 90 minus theta. Okay, again I tell you, start from here, 0 degree or 360 degree, anything you can say, because 0 and 360 are same only. So 360 minus theta, fourth quadrant, since we have 270 here, 270 minus theta, third quadrant, since we have 180 degree, this is 180 degree minus theta, second quadrant. Here we have 90 degree, so 90 degree minus theta, first quadrant, clockwise direction. Now for 90 degrees and 270 degrees, remember, sine becomes cos, cos becomes sine. We have to change that, sine into cos, cos into sine, sine theta into cos theta into sine theta. Now tan becomes cot, cot becomes tan, particularly for 90 and 270. And secant becomes cosecant, cosecant becomes secant. Similarly for 180 degrees and 360 degrees, even for 0 degree, 0, 0, 180, 360 in x-axis, 90 and 270 in y-axis. Sine becomes sine only. Similarly the rest. Cos becomes cos, tan becomes tan, cosecant becomes cosecant, secant becomes secant, cot becomes cot, particularly for 0 degree, 180 degree and 360 degree. So while working out the problem, you can understand the concept very well. Now I get into that exercise 3.3, first problem. Before that, you note down this also. Note sine of minus theta, that is equal to minus sine theta, cos of minus theta, that is equal to cos theta, tan of minus theta, that is equal to minus tan theta, cot of minus theta, that is equal to minus cot theta, cosecant of minus theta, that is equal to minus cosecant theta. Finally, secant of minus theta, that is equal to secant theta. Here cos of minus theta, cos theta, secant of minus theta, secant theta. These two are even functions. Others and all, look at that, here minus, here minus, here minus, here also minus. That and all odd functions. Okay. These two even functions, others and all odd functions. Now you can get into that exercise. Exercise 3.3, problem number 1. Exercise 3.3, question number 1. Find the values of totally 7 subdivisions are there. We can do one by one. Subdivision number 1, sine 480 degrees. First subdivision, sine of 480 degrees. That is equal to sine right as it is 480 itself. We know that one rotation is 360 degree. Full rotation 360 degree. Balance 120. So 360 plus 120, that is equal to 480. Now look at that. What's the first angle here? 360 degree. Now for 360 degree, sine becomes sine. No change at all, right? You write sine as it is. After that, what's the angle over here? 120 degree. Write that one. Whether it is minus 120 or plus 120, write 120 degree only. Now, sine of 360 plus theta, what form it is? Sine of 360 plus theta lies in which quadrant? We can see. 360 plus theta, 360 plus theta lies in which quadrant? First quadrant. First quadrant, everything is positive. Therefore, this sine also positive. Now, sine 120 degree, how to separate? Sine right as it is. This 120 degree can be written as 90 plus 30 or 180 minus 60. 90 plus 30 or 180 minus 60. I take 180 minus 60 degree. The first angle should be, the first angle here, it should be 90 degree or 180 degree or 270 degree or 360. It should be the multiple of 90 degree only always. Remember, don't write 120 degrees 100 plus 20. 100 plus 20 also 120 degree only. The first angle what you are writing here, that should be the multiple of 90 only always, right? So you can write 90 plus 30. 90 plus 30 is 120 or 180 minus 60. I have taken 180 minus 60. Again, what is the first angle here? 180 degree. Look at that. For 180 degree also, sine becomes sine. No change at all. So this sine becomes sine only. What's the angle here? Already told you whether it is minus or plus. You have to consider this angle 60 degree. After that, 180 minus. Look at that. 180 minus. Sine of 180 minus. 180 minus lies in which quadrant? We have to verify. 180 minus, where it is? Here it is. 180 minus lies in which quadrant? Second quadrant. Second quadrant, which one is positive? Sine and its reciprocal cosecant positive. Sine and cosecant positive. What is here? Outside the bracket we have sine. Therefore, it is positive. It is also positive. Don't look at this one. You have to consider which is outside the bracket. We have sine. Sine is positive in second quadrant. Therefore, it is positive. We know the value of sine 60 degree. Sine 60 degree value is root 3 by 2. That is the value of sine 480 degree. Okay. Now subdivision number 2. Subdivision number 2, sine of minus 1110 degrees. We know that sine of minus theta, that is equal to minus sine theta. Therefore, minus sine of 1110 degrees. I write the reason, since sine of minus theta, that is equal to minus sine theta. That is equal to minus sine of For one rotation, 360 degree. We can go for 3 rotation, maximum of 3 rotation here, because 3 into 360 degree, that is equal to 1080. 3 into 360, 1080. Here we have 1110. So balance of 30 degrees. 1080 plus 30, that is equal to 1110 degrees. That is equal to minus, right first, this minus. After that, whether it is 3 times or n times, here you have to consider this angle only, 360 degree. For 360 degree, already I told you, sine becomes sine, no change at all. Here it is. For 360 degree, 180 degree, 0 degree, sine, sine only, cos, cos only, no change at all. So write sine as it is. What's the angle over here? 30 degree. After that, 360 plus, look at that, 360 plus lies in which quadrant? We have to verify. 360 plus theta lies in first quadrant. Everything is positive, all positive. Therefore, already I have written this sign, don't get confused. What is here? Sine. The sign positive, it is also positive, right? That is equal to minus sine 30 value, that is 1 by 2. That is the value of sine of minus 1110 degrees. Subdivision 2 over. Now subdivision number 3, cos 300 degrees. Subdivision number 3, cos 300 degrees, that is equal to cos of 300 degrees can be written in two ways. 270 plus 30, the first angle should be multiple of 90. Already I told you 270 is a multiple of 90 only. So 270 plus 30, or you can write 360 minus 60. I take 360 minus 60. 360 minus 60, that is equal to 300 degrees. What's the first angle here? 360 degree, that's a multiple of 90 only. Now for 360 degree, you know that cos becomes cos, no change at all. For 0 degree, 180 degree, 360 degree, no change at all. Write that cos as it is. What's the angle here? 60 degree. Don't consider the sign, you have tried to only 60 degrees. After that, 360 minus lies in which quadrant? We have to verify. 360 minus, here it is. 360 minus lies in which quadrant? Fourth quadrant. Cos positive. Cosine means cos. Cos and secant, and its reciprocal secant only positive. Cos and secant positive. What is here outside the bracket? Cos. It is positive, therefore it is also positive. Cos 60 value you know very well, that is equal to 1 by 2 over. Subdivision 3 is over. Now subdivision number 4. Subdivision number 4, tan of 1050 degrees. Tan 1050 degrees, that is equal to tan of, we can go maximum of double rotation only, 2 into 360 degrees, because triple rotation 3 into 360, that is 1080, we have only 1050. So maximum double rotation, one rotation 360 degrees, double rotation 2 into 360, 720 degrees, plus 330 degrees. 720 plus 330, that is equal to 1050. Now what is the angle here? Even though double rotation, you have to consider this angle only, 360 degree. For 360, tan becomes tan, no change at all. What's the angle here? 330 degrees. After that, 360 plus lies in which quadrant? 360 plus, here it is, lies in which quadrant? First quadrant. Everything is positive, all positive, therefore tan positive, it is also positive. After that, 330, we don't know the value of 330 degree, how to find that one? So tan 330 can be separated as 360 minus 30 degree, or 270 plus 60 degree. 270 plus 60 is 330. 360 minus 30 also 330. I consider this one. Okay, that is equal to, for 360, tan becomes tan, no change at all. What's the angle here? 30 degrees. 360 minus lies in which quadrant? 360 minus, here it is, lies in which quadrant? Fourth quadrant. Fourth quadrant, cos and secant only positive. Cos and its reciprocal secant only positive. What is here? Tan. Outside the bracket you have to consider. What is that? What is here? Tan. Therefore, it is negative. That is equal to minus tan 30 value, you know very well, that is 1 divided by root 3. Now subdivision number 5. Subdivision number 5, cot 660 degree. Cot 660 degrees. That is equal to cot of, we can go for one rotation only, double rotation 720. So 360 plus 300. 360 plus 300, that is equal to 660. Right. For 360 degree, look at the first angle 360 degree, cot becomes cot, no change at all. So cot angle 300 degrees here. After that, we don't know the value of 300. How to separate 300? That is, before that, 360 plus lies in which quadrant? 360 plus lies in first quadrant. Everything is positive only. Therefore, cot positive, it is also positive. After that, 300 can be written as 360 minus 60 or 270 plus 30. The first angle should be multiple of 90 degree. Remember, 360 minus 60, that is equal to 300. What's the angle here? 360 degree. For 360, cot becomes cot. No change at all. Cot, what's the angle here? 60 degree. Now 360 minus, look at that, 360 minus lies in which quadrant? That is in fourth quadrant. Fourth quadrant, cos and secant only positive. Cos and secant only positive. What is here outside the bracket? Cot. It is negative. So introduce minus word here. That is equal to minus cot 60 value is 1 by root 3. Now subdivision number 6. Tan 19 pi by 3. Tan of 19 pi by 3. If you change that radian into degree, it will be easy for you. I change it first. 19 pi by 3. How to change a radian into degree? You know very well. Write that 19 pi by 3 into 180 by pi. For converting radian into degree, multiply by 180 by pi. Pi get cancelled. 3 table how many times? 60 times. That is equal to 0. 9 6 are 54, balance 5. 6 1s are 6 plus 5, 11. 1140 degrees. Okay. So that is equal to tan of 1140 degrees. So we can go for triple rotation. Tan of triple rotation 3 into 360 degree. One rotation 360 degree, triple rotation 3 into 360, that is 1080. 1080 balance 60 degree. 1080 plus 60 degree, that is equal to 1140 degrees. Now what's that is equal to, for 360 degree, tan becomes tan. No change at all. 60 degree, right as it is. Now 360 plus lies in which quadrant? We have to verify. 360 plus lies in which quadrant? First quadrant, all positive. So here we have outside the bracket tan, it is positive, therefore it is also positive. What is the value of tan 60 degree? Tan 60 degree value is root 3. So subdivision number 6 over. Now subdivision number 7. Subdivision number 7, sine of minus 11 pi by 3. We can change the radian into degrees first. That is equal to, before that, sine of minus theta, that is equal to minus sine theta, minus sine 11 pi by 3. Right, the reason, since sine of minus theta, that is equal to minus sine theta. Next, sine, right as it is, we can change the radian into degrees. 11 pi by 3, that is equal to 11 pi by 3 into 180 by pi. If you multiply by 180 by pi, the radian will be converted into degrees. Pi get cancelled. 3 table how many times? 60 times. That is equal to 11 into 60, that is 660 degrees. 660 degrees. that is equal to minus, right as it is, sine of, can go for one rotation only, that is 360 degrees, balance of 300. 360 degrees plus 300, that is equal to 660 degrees, that is equal to minus of, then for 360 degrees sine becomes sine. What's the angle over here? 300 degrees. Now 360 plus lies in which quadrant? 360 plus lies in first quadrant only, all positive. Okay, so outside the bracket we have sine, therefore it is positive, it is also positive. This minus already I have written, don't get confused over that. That is equal to minus, for 300, how to find the value of sine 300? So write sine as it is. 300 you can write 270 plus 30 or 360 minus 60. 360 minus 60, that is 300. The first angle should be the multiple of 90 always. That is equal to, write this minus first, then for 360 sine becomes sine, no change at all. What's the angle here? Don't consider the sine, write the angle 60 degree. After that, for 360 minus lies in which quadrant? We have to verify. 360 minus, here it is. 360 plus in first quadrant, 360 minus in fourth quadrant. Fourth quadrant, cos and secant only positive. Cos and its reciprocal secant only positive. We can verify. Which one is outside the bracket? We have sine. Therefore, it is negative. So, introduce minus. Already we have one minus outside the bracket. Minus into minus plus sine 60. Sine 60 value is root 3 by 2. Subdivision 7 also over. So, problem number 1 is completed. I will be teaching the problem number 2 in the next video. Thank you, children.